Welcome to the DIY Honda Garage channel. The DTC P0962 refers to a malfunction in the AT clutch pressure control solenoid valve A. This error indicates either an open or short in the solenoid's electrical circuit, which is essential for controlling the hydraulic pressure in the automatic transmission. The AT clutch pressure control solenoid valve A is situated within the transmission assembly, playing a vital role in ensuring smooth operation and optimal gear shifting. When the solenoid fails, it can adversely affect the vehicle's performance. The diagnosis should begin with an assessment of the detailed diagnostic trouble code, along with reviewing any freeze frame data and onboard snapshots recorded with the HDS or Honda Diagnostic System. It's crucial to distinguish that this issue may arise solely from electrical faults rather than mechanical problems in the transmission. This understanding sets the foundation for the following troubleshooting steps. The AT clutch pressure control solenoid valve A is an integral part of the Honda CRV's transmission system, responsible for regulating clutch pressure. This regulation is crucial for the automatic transmission operation, as improper pressure can lead to harsh shifting or slipping. The solenoid receives signals from the powertrain control module, PCM, which adjusts the hydraulic pressure based on various factors such as vehicle speed and engine load. The solenoid is typically located within the transmission assembly, making it somewhat inaccessible without removing or displacing other components. Understanding these components and their locations is essential in diagnosing and rectifying issues related to the DTC P0962. Furthermore, it is imperative to confirm that the issue does not stem from a mechanical failure in the transmission, as this code specifically pertains to an electrical malfunction. The primary cause of DTC P0962 is an electrical circuit issue, suggesting a malfunction in the connection or integrity of the wiring related to the AT clutch pressure control solenoid valve A. A blown number B7 fuse often accompanies this code, indicating a potential overload or short circuit. If the fuse is blown, it's essential to not only replace it, but also diagnose the circuit for any underlying shorts that could lead to repeated failures. Other significant contributors to this issue include wiring problems, such as open circuits or poor connections between the solenoid and the PCM. Each possibility will warrant a distinct series of troubleshooting steps to isolate the exact cause before moving on to repairs. Several symptoms may manifest due to the AT clutch pressure control solenoid valve A malfunction indicated by DTC P0962. Firstly, drivers may experience harsh shifting, often described as a jolt when the vehicle changes gears. In severe cases, the transmission may slip, failing to engage properly or causing a loss of power during acceleration. Additionally, the check engine light is typically illuminated, prompting the need for a diagnostic assessment. These symptoms can severely affect the vehicle's drivability, emphasizing the importance of timely attention to the issue. Awareness of these symptoms can assist technicians in efficiently identifying the root cause of the problem during the troubleshooting process. The first troubleshooting step involves confirming the presence of DTC P0962 using the Honda Diagnostic System, HDS. Start by turning the ignition switch to on, which allows the system to access diagnostic data. Next, it's crucial to record any freeze data, as this information can provide context for when and how the code was triggered, offering insights into potential underlying issues. Once the data is collected, clear the DTC from the system's memory and start the engine, allowing it to run for at least 1 second. This approach ensures that you are not troubleshooting outdated information, and by checking for both pending and confirmed DTCs after starting, you can confirm if the issue persists. Successful verification lays the groundwork for further diagnosis. The second step focuses on checking the ING1 FI ECU line, which is key for verifying electrical integrity. First, turn the ignition switch to lock, 0. Then use the HDS to jump the SCS line. This short connector allows access to diagnostic functions within the HDS. Next, disconnect the PCM connector A, which contains multiple essential circuits. With the connector disconnected, turn the ignition switch back to on and measure the voltage across test points 1 and 2. This step checks the voltage from the IG1 FI ECU to a known body ground. If voltage is present, it indicates the wire is intact, enabling progression to the next troubleshooting step. However, if voltage is absent, this suggests either a blown number B7 fuse or an open circuit, necessitating further inspection and repair. Step 3 entails checking the operational status of the AT clutch pressure control solenoid valve A. Begin by reconnecting the PCM connector A, ensuring that it is properly seated for accurate electrical contact. Next, turn the ignition switch to on 2 and navigate the HDS to the miscellaneous test menu. Here, select the clutch pressure control linear solenoid valve A setting to initiate the testing procedure. During this operation, the HDS will provide real-time feedback on whether solenoid valve A operates within expected parameters. If the HDS indicates a normal status, it confirms functional integrity of the solenoid. Conversely, a failure indicates further issues may exist within the solenoid or its associated circuitry, directing the technician to proceed to the subsequent step. In Step 4, the aim is to further verify the functionality of the AT clutch pressure control solenoid valve A. Begin by navigating to the clutch pressure control solenoid valve control menu on the HDS and set the solenoid to draw 1.0 A's of current. This will provide a load that can reveal potential weaknesses in the system. Next, carefully monitor the OBD status for DTC P0962 in the corresponding menu. If the HDS indicates a failure, this reaffirms that the system is experiencing issues that need to be addressed. However, if it indicates a past condition, it suggests the solenoid is functioning correctly at the moment, but it may warrant further investigation for intermittent issues. The HDS feedback is crucial for guiding future troubleshooting steps. The fifth step involves performing an internal resistance check on the AT clutch pressure control solenoid valve A. Begin by disconnecting the 2P connector linked to the solenoid, which removes it from the circuit for accurate testing. Next, measure the resistance between test points 1 and 2 within the disconnected circuit. This will allow for confirmation that the solenoid is operating within the specified range of 4.8 to 6.0 ohms. If the measured resistance falls within this range, it indicates that the solenoid is functioning correctly. However, if the reading is outside this range, it necessitates replacing the AT clutch pressure control solenoid valve A, as its integrity is compromised and affecting vehicle performance. Proper documentation of resistance values is essential for accurate diagnostics. Step 6 is crucial for determining the integrity of the PG2 line associated with the compact AT clutch pressure control solenoid valve A. Begin by checking for continuity between designated test points 1 and 2 when the vehicle is in the IG lock 0 position. Both the AT clutch pressure control solenoid valve A, 2P connector, and the associated areas must be disconnected to prevent interference during testing. If continuity is confirmed, it indicates that the PG2 wire is functioning properly, allowing for a transition to Step 7. Conversely, if continuity is absent, This suggests an open circuit that requires careful inspection and repair between the solenoid and ground reference. Addressing any identified open circuits is crucial for restoring proper solenoid function. In the seventh troubleshooting step, focus shifts to the linear A+ wire that connects to the AT clutch pressure control solenoid valve A. Start by jumping the SCS line using the HDS as a preparatory measure. Then, disconnect the PCM connector B to isolate the line under examination. Conduct a continuity check between designated test points to confirm whether the linear A+ wire has a short circuit to ground. If continuity is present, it indicates a short condition within the wiring harness, necessitating immediate repair. However, if no continuity is found, it suggests the linear A+ wire is intact, permitting you to proceed to the next troubleshooting phase, thus confirming the previous section's integrity and functionality. The eighth step is dedicated to checking for continuity in the linear A+ line itself. As in earlier checks, ensure the circuit to the AT clutch pressure control solenoid valve A and the PCM connector B are both disconnected while under the IG lock 0 condition. Examine continuity between the solenoid connector and the PCM connector, ensuring there is an uninterrupted path between the two. If there is continuity, it confirms the integrity of the wire. However, if the circuit is open, further inspection is needed to trace the wiring and identify where the break may have occurred. After ensuring the line is intact, it is also essential to update the PCM software if required, or substitute a known good PCM before concluding the troubleshooting process. The final repair verification process involves a systematic approach to ensure that all issues have been resolved effectively. Begin by reconnecting all necessary connectors to ensure all components are secure and ready for operation. After reconnecting, turn the ignition switch to on, and use the HDS to clear any remaining DTCs from memory. Following the reset, start the engine and allow it to run for at least 1 second to recheck for the DTC P0962. Monitor the OBD status to verify if it indicates passed, failed, or not completed. A passed condition confirms successful repairs made during the troubleshooting processes. If the status indicates otherwise, further investigation is warranted, possibly revisiting previous steps to confirm all repairs and connections are properly executed before finalizing the process. To prevent future occurrences of DTC P0962, regular preventive maintenance is essential. An important proactive measure involves performing periodic electrical system checks to ensure that all connections remain secure and functional. Additionally, it can be beneficial to inspect the wiring associated with the AT clutch pressure control solenoid valve A for any signs of wear or damage. Furthermore, maintaining proper transmission fluid levels can prevent overheating and excessive strain on hydraulic systems that may contribute to premature failure of solenoids. Implementing these preventive measures will significantly extend the lifespan of the transmission components, thereby reducing the likelihood of encountering similar DTC issues in the future. In conclusion, addressing DTC P0962 requires a structured diagnostic approach, focusing primarily on the electrical infrastructure surrounding the AT clutch pressure control solenoid valve A. Identifying and rectifying electrical issues early on can prevent more severe transmission problems down the line. It is essential to recognize the solenoid's role within the overall operation of the Honda CRV's transmission system, as it significantly impacts performance and drivability. By adhering to the outlined troubleshooting steps and implementing preventive maintenance practices, vehicle owners can mitigate the risk of future DTC occurrences. Timely intervention is imperative for ensuring the reliability and longevity of the vehicle's transmission system. Please like and subscribe to the channel. See you next time.